Welcome to this month in IPFS, our February edition of this live stream. Drop us a line, let us know where you're joining us from. We can see it all in the chat. And yeah, today we have two great guests who are going to join us to talk about some interesting stuff and developments that are happening in the IPFS ecosystem. And specifically, we have David Aronchik, who's leading the Compute Over Data initiative at PL. And he's going to join to talk about the Bacalhau project. I hope I'm not mispronouncing that. It is a Portuguese word, so forgive me. And we also have Alex Possides, who's the lead for Helia. He's also done a lot of work on JS, libp2p, and JS IPFS. Helia is a sort of the new reincarnation of the IPFS implementation in JavaScript. So hello, Alejandro. Thank you for joining. It's good to have you. And so with that, I also want to say that you can drop your questions in the chat as they come along. And if you're watching this after the live stream, you can just drop it in the comments and hopefully we'll get back and answer your questions. So really great to have you all join, and there's so much stuff happening in the ecosystem. So after we have our two guests, I'm also going to go through some of the news in the IPFS ecosystem and some other things that are happening. So with that, I want to bring Alex to the stage. Alex, wait, let me just get you on here. How's it going, Alex? Good to have you.
Hi, it's going pretty well, thanks.
So you've been hard at work on Helia, which we announced already last year. I remember, I think it was around November last year that we published the state of IPFS in JS. And tell us a little bit about like Helia. I know you have a presentation prepared, but like tell us a little bit about your work in IPFS land and specifically in the JS ecosystem.
So I work for PL. I'm on the IP stewards team, and I look after most of the JavaScript stack, I think it would be fair to say. And so the work with Helia is to attempt to kind of apply the learnings that we've had for the past few years on JS IPFS to a new implementation that will be, make you stronger, faster, and more productive. Um, Yes, that's Healer in a nutshell, I think.
Cool. And you have a little demo prepared, and you're going to actually dive deeper. Can I bring your screen onto the stage?
So many demos.
All the demos. And also a quick reminder that we have a raffle going on. All you need to do in order to participate is go to the community calendar, the IPFS community calendar. I'll drop a link to that right now. And you need to click on the subscribe button. Once you subscribe, then you'll join the raffle. All right, and now we have Alex's presentation. So with that, okay. Cool, you're good to go, Alex.
Great. Can you see the screen? Everything's frozen for me.
Yeah, we can see the screen. Oh. Alex? You still with us? Let's retry that. Okay, we lost Alex. He'll be right back with us. Let's see. Technical difficulties happen on these live streams, but we've got Alex back. Hello, welcome back, Alex.
I got one of those, oh snap, Chrome crashes. So hopefully it doesn't happen again. Otherwise, I'm going to be doing a lot of miming about Helio rather than showing you useful things.
Okay.
Okay.
You're good to go.
Not better. All right. So, oh no, nothing again. Did I freeze again?
We can see the It's Me slide.
It's me, Alex Potsides, aching brain on the internet. Yeah, like I just said, I'm in the IP stewards team. I'm the maintainer for JS IPFS, JS libp2p. And yeah, this talk is not about me though. This talk is about Helia. Helia is a new implementation of IPFS, all done in JavaScript. It needs to be lightweight, and it's going to be lovely. It's going to be very minimal. It's going to get out of your way. It's going to let you extend it. That is Helia. So what is it? Through this, it's so the API for Helia is very simple. I mean, most of the things in Helia are a response to perceived deficiencies in JS IPFS. So one of the things people always talk about is the fact that it's big. And one of the things that makes it big is that it has an expansive API, which is very hard to understand when you first see it. There's lots of ways to do lots of things, lots of repetition and duplication. And that's it's bad for users, it's bad for maintainers, it's just generally bad. So the idea with Helia is very much to have a minimal API that gives you the very, like the smallest amount of stuff that you would need to do pretty much anything. And that is basically like what is IPFS when it comes down to it. One of the definitions is a way of moving the blocks behind CIDs around. So you have blocks. So what's a block? So a block is when you add a file to IPFS, you chunk it up into blocks. Each block has a CID, and a file can be made up of multiple blocks if it's very big. So you need somewhere to put that block. So you need a block store. So when you import your file and it gets turned into chunks, they all go into the block store. That's great because you can put blocks in, you get blocks out. If you don't have the block, then what? Well, then you need to go to the network. So the way IPFS fetches blocks from other peers is bitswap. So bitswap wraps the block store. So if the block that you're requesting isn't present in the block store, then bitswap will try to pull it from the network. That involves sending your want list to other peers or doing a DHT query for providers of the CID, but it's all transparent to the user. What else? So you need a data store. The data store holds application-specific data. So if you're doing things like publishing IPNS records, you will store those IPNS records in your data store. If you are, if your libp2p node is doing things like persisting peer information or DHT records, all those things need to live somewhere, so they live in the data store. So you need a data store. What else do you need? Well, you kind of need pinning, because if your block store grows very large, maybe you want to trim it a little bit. So you need to be able to tell you which tags are important and which ones are not. And the ones that aren't important will get deleted. So you need pinning and garbage collection. And then to do all the network stuff, the real magic of IPFS, you need libp2p. To find other peers, connect to them, exchange messages, and actually get the blocks. Because of course bitswap works over libp2p streams. So that's it for the Helia API, which is already quite a lot when you read it all out loud. But very much the idea is that is it. This is going to ship v1 and it's never going to ship v2. I mean, that's a lie. Of course it's going to ship v2. Almost certainly very soon after releasing v1. But the idea is that you will not see significant API churn in the core Helia API. All the interesting stuff and the changes will happen at a higher level, and we'll see more of that later. So, what is it? And what else we want? We want it to be faster. We want to favor composition. So this is this idea of extending Helia through other things, but we want it to be faster. What does that mean? Right. Well, so some things this lovely graph has come from this pull request number 36 on the Helia repo, which is linked to where I did a whole bunch of benchmarking of performance for. It all came about from garbage collection, wanting to make garbage collection fast. And so part of that, those benchmarks involve adding blocks and adding pins and all this kind of stuff. So it's actually generated a bunch of secondary metrics. So this is benchmarking the PR of Helia against the latest version of Kubo. And you can see that because because Kubo's block import APIs are basically one at a time. Which, obviously you can parallelize. But the way Helia has done it, it's turned it on its head, and it's allowed the implementation of the block store to control the concurrency. So here, this is the file system block store is pulling blocks as fast as it can, or as fast as it's configured to, which has resulted in a dramatic speed up of adding blocks to Helia versus adding them to Kubo.
Right.
The same thing with pins. So the pinning situation in Kubo is what the one in IPFS used to be, which is all the pins are stored in an enormous DAG, and every time you change to add pins, you have to update this DAG, which means that the more pins you have, the longer it takes to pin something, or at least the longer it takes to add that number of pins. The way Helia is doing it is the pins are not related to each other. So there is a tiny increase there that you can't really see from the blue line at the bottom, but it's way more efficient as your pin sets grow larger and larger. And then the result of all this is the garbage collection speed. So this is like, you can see I was running this on my laptop, right? And so I was doing other things. So the lines are a little wavy, but hopefully the trend line kind of makes it clear that over time, this idea of storing, not using a DAG to store pins, instead Helia uses reference counting. So whenever you pin a DAG, we walk the DAG to make sure that all the blocks are there. And then as we walk the DAG, when we encounter blocks in the DAG, we increase the reference count of which pins refer to that block. So then, and if there are no pins that and when we remove a block from the block store, we decrement the count. So if the count is 0, then we just say, well, there's nothing that's referring to this anymore. And so garbage collection just becomes a case of looping over the blocks and just saying, do we have a record for the reference count for this block? If not, delete it. Which makes it much faster, because this is all written in JavaScript as well, which is typically not a very CPU friendly language. So it's actually pretty good to be able to get it to run this fast. So I'm very excited about this kind of thing.
And reference counting.
So we have.
So is this the first time that we're using reference counting as a way to do garbage collection in IPFS implementation? Because I believe Kubo also doesn't do reference counting.
It's the first one that I'm aware of.
Okay.
Put it that way.
Cool.
So yeah, what else? So UnixFS. So we've got a library shipped that is the UnixFS implementation for Helia. It extends Helia rather than adding methods to it, but we'll see more of that in the demo. But basically, the thing that I want to emphasize is we've attempted to make it have an ergonomic API. So the existing IPFS APIs, it's really hard to do things like mutate a DAG outside of the MFS. So you typically end up either copying a CID into your MFS, doing some mutations on it, and then using the CID or exporting it or pinning it differently or some other way, which is kind of it's not the most straightforward. So people end up doing things like dropping down to the object API to like add a file or a folder to a directory, which it takes you away from that file system abstraction, and suddenly you're knee deep in DAGs and all this other stuff that you don't really want to think about if you just want to deal with files. So the UnixFS API in Helia is very much focused on making you allowing you to use familiar constructs.
Is this how is this different to MFS?
It will make more sense in the demo, I think. Okay. So MFS has one root CID that is persisted in the data store, but it's hidden from you, and all your operations are done using string paths on the DAG that CID represents. Whereas this doesn't have that. So you could actually, so with this, whenever you mutate a DAG by adding a file or a folder or something, you'll get a new CID back that is the root of that DAG.
So okay, so it's a bit like persistent data structures that like immutable persistent data structures, right? Where you can sort of mutate them, but every time you do a mutation, you get a new SID. Except in this case, you're not sort of operating on a global namespace that is like the MFS root, right? You can do this on individual SIDs.
Exactly. So you could even roll your own MFS by just
Mm-hmm.
persisting whatever the
Yeah.
final CID is that you get back from your operation. And that also lets you do things that you can't do with MFS, like maybe having multiple MFSs.
Mm-hmm.
IPNS is there, it works, you should use it, it's great. I think Daniel might talk about this a little bit more later or some other time. I'm not going to go deep into it now, but it's great, super good. Anyway, enough talking, so much talking. I'm very sorry, very wordy, very chatty. Time for a demo. So I'm going to share my other screen. Hopefully this works. It doesn't crash again. Uh-oh. Please update your screen permissions.
I think we're having some trouble with the chat. Let's see. So we're waiting now for the screen to load. And meanwhile, if you've just joined, we're now looking at Helia. Helia's latest implementation of IPFS. And if I can get the chat to work, we're having some technical difficulties today. But I will drop a link to the Helia repo. Okay, chat seems to work. All right, I'll drop a link to the Helia repo. We also have a demos repo. That's just a short link. Okay, we lost Alex again. Let's see if we can have him join us. And I will drop also a link to the examples repo for Helia, which I've been playing with the last couple of days. We're going to get more examples out there. But let's see. Demo gods are not with us today, so bear with us. I see there's 9 people still here. Appreciate you joining. Okay, Christian is asking, can I run Helia with IPFS cluster or would I run it without it? Okay, so IPFS cluster, right, that's the way that you can scale basically a Kubo deployment. You can have multiple Kubo nodes that are sort of syncing with each other, the same pin set. And so the question is like, can you run Helia with it? Well, Helia is interoperable. So if you have Helia running, say, on Node.js, and you have a bunch of Kubo nodes that are part of an IPFS cluster, then they do interoperate and they can sort of switch blocks in between them. But I guess it comes down to a question of what are you trying to do? I think if you're trying to sort of scale like an IPFS deployment to more than one node, then I'm not sure that Helia would probably be your best bet. Alex, I'm just responding. Someone had a question about whether they can run Helia with IPFS cluster. But it's good to have you back, Alex, despite all technical difficulties. Are you able to share your screen this time?
Let's try.
Okay, let's bring it up.
Yes.
Yeah, it seems to be working. Can you zoom in a little bit? It's a bit pixelated at this point, but that's a bit better. Okay, yeah, that works.
Okay, so what have we got? So we create a block store, if you remember from the earlier slides. Then we create a data store for the application data to live in. We create a libp2p node. So this is, if you've used just libp2p in the past, exactly the same. There's no special configuration here. And then you create your Helia node. So there's just a function, create Helia, pass block store, data store, and libp2p in. I'm not going to start it because I'm not doing any network operations. Right. Anyway, so UnixFS is a function that's exported from the UnixFS module. So I invoke it, I pass in Helia, and suddenly I have the power of UnixFS at my fingertips. So what am I going to do? Right, well, let's start with creating an empty directory. So I'm just going to create add directory, which is going to give me a CID. So first thing I can do is I'm just going to console log this CID.
This is probably a familiar CID, right? Like the empty directory CID is something that probably, if you Google it, you'll find more instances of it, right?
Wow. Yes. So CID is not defined. It's because I'm live coding. Is it though? It's a different CID. The reason it's a different CID is because we're trying to push modernization here. So the first thing that you'll notice is it doesn't start with QM. This is a V1 CID and not a V0 CID. So you can, if you wish, if you so wish, you can go old school and specify CID V0, in which case, yes, now you got this very familiar looking CID. This is one of the CIDs I may get a little excited and tattoo down the inside of my arm one day because it's so iconic. Unless it's in V1, in which case no one recognizes it. So maybe that's a terrible idea. I'm not going to do that. That would be awful. Okay, so what else are we going to do? Right. So the next thing we can do is we can like make a directory inside this. So we've got like an updated CID equals fs muctor. So we're going to make a directory. Where are we going to make the directory? Well, we're going to start with the empty dir, and we're going to give it a name.
Okay, so these are kind of like operations that are basically mutating on a SID.
Exactly. So now we have this updated CID, and we need to see what's inside it to prove that we've changed something. So what we can do is we can console info await all fs ls. So we're going to list. We can start by listing the empty CID. And then we're going to go again and we're going to list the updated CID.
What is this all method? Where is that all method coming from?
If you've used any async iterators, you will recognize it from it all. So all it does is, because these directories can be absolutely enormous, there's essentially no size limit on a UnixFS directory because it can be a shard. So you could have a very large number. You don't ever want to store, like you only want to return like an array of files because that array at some point will be bigger than the surface of the planet. So they return an async iterable and it all just collects it. So it's good for demo purposes.
Okay, so it's a way basically to kind of like collate essentially in like an async iterable. It'll sort of iterate over it and just return it. And one thing that I wanted to pause there, if you can hover again over the .ls, I think it's worth pointing out that Helia is actually written completely from the ground up in TypeScript, which means that even if you're writing just JavaScript code consuming this in VS Code, you get all of the type annotations. So you get that like much better developer experience. And obviously, if you were using TypeScript, then you would get all of these errors kind of like earlier, even the one that you had with like the misnamed variable.
Exactly, absolutely. So if I run my thing, see what happens. So look, this is the first CID, there's nothing in it. And then in the updated CID, we've got a directory, its name is foo, which is what we added. And we have some extra metadata so we can list the directory contents. And then we can interrogate the actual UnixFS encoding of the directory root. Very nice. What else can we do? So we can do things like add a file. So let's fs const updated another final dir CID equals await fs dot, well, actually, let's create our file first. So file cid equals await fs add, let's just add bytes. So this is just a convenience that just lets me pass in one unit int array. Other methods are available. So for example, I could, if I wanted to, I could do fs add byte stream, and I could create a read stream of a file on the file system, or anything else that can iterate bytes. So now I have a file CID, and then I can copy I can copy my file CID where into my updated dir CID with a name. So like bar.text, and then I'm going to ls my final dir CID, and we're going to see what we got. Here we go. So we got our directory that we created, and we have the file that we've added. Again, we have content.
Is this file inside the foo folder? It's a bit hard to see the full folder structure here. But updated SID is the, okay.
So it's just a flat directory. So I've copied it into updated CID, which was the directory that contains the foo folder, which is created from the original empty directory CID.
Okay, and if you wanted to copy that file into the foo directory, what would it look like?
So you can do a path foo.
Okay, so you can use the paths in the cp command, like the destination.
Exactly.
Okay.
Exactly. So anyway, yeah. So I have my file, and I have my directory, and these CIDs. And of course, all the blocks that correspond to these CIDs are still in the block store. So I can essentially go backwards in time, and look at earlier versions. I haven't actually lost anything. What if you don't want them in the block store? Then you might want to run garbage collection. So you can await helia.gc, and that will run garbage collection. But how will you know? How will you know what's going on? Well, you can pass in objects, and so one of the things that you can pass in is this on progress handler. So on progress is it's something very strange. Okay, maybe it's better. Anyway, okay. So on progress is a kind of a standard way of doing things we're trying to introduce into the whole Helia stack. So you can see things, you can see what's happening. So you get these events, and then you need to use some kind of disambiguator. So type equals, and so we have this Helia GC deleted event type, which through the magic of TypeScript, it's told us this is one of the kind of events that we can expect to receive. So I could look at deleted detail. All the events have a detail field which has context-specific information. And what is it? Oh, it's a CID. It's a CID. Incredible. Right. So if I run GC, I should now see some deletion events.
Is it though, like if I'm running Helia, is it my responsibility to call the garbage collection, or will it ever run does it have sort of like a ticking function that will automatically do the garbage collection?
It's opt-in at all times because it is an expensive operation. So it's not the kind of thing that you want to just run by accident or have, in the middle of your very important thing, whatever it is your application is doing. So it's very much an opt-in operation. It's not like a garbage collected language. Anyway, so running that, so you can see I have my folder, I have my file, and then I've deleted all the CIDs. So I've received these as events, which is cool.
And wait, it deleted all of them because none of them were pinned, right? You were just creating them.
So I could pin the CID first. Pins add that CID, final dir CID, and I run it again, and I can see fewer things deleted. No dag walker found. Oh, I need to add something to the thing. Yeah.
A dag walker.
Did I add the dag walker? Yeah. This is all very much under development. Yeah, so when you're pinning a DAG, you need to know how to recurse through a block and find linked CIDs in that block. And each codec has a different way of doing it. So if you look at a CID, a V1 CID, it has three interesting fields. It has a version, which is version 1, has a codec, and has a multi-hash. And so the multi-hash is the hash of the block. The codec is essentially how to interpret the block. So there's a codec for DAGPB, which is walk back to UnixFS. And so you need to tell Helia how to walk through UnixFS DAGs. It's very simple. It's gonna get bad.
I mean, I don't think it's that simple, but yeah, I'll play along.
Fair enough.
But maybe while you're doing that, I can also share the CID inspector just to kind of like unpack a little bit of what you said there. So you were referring to how a SID can have like a bunch of these functions, and one of the things it has is the multi-codec. So here I just dropped a SID. This is literally just a SID of an image that is stored, and this is basically the Merkle DAG protobuf. That's the codec that you were referring to, right?
Mm-hmm.
Okay, cool. Sorry. So you've got a DAG walker there, and you told it that it's a PB walker because it has to traverse basically a protobuf DAG PB codec.
Exactly. Like Helia will likely ship with some of these by default because UnixFS operations are pretty common, or perhaps when you create your UnixFS, more likely it will add the DAG walker to Helia transparently. Anyway,
right.
So as you can see, there's a DAG walker. It has a walk function. It takes a block. You use DAGPB to decode the block, and then all the links, and it just yields all the links, the hashes from all the links in the block, and the hashes are CIDs. So if I run this again, you'll see I've only deleted one CID this time. Demo, done.
That's great. So one final question I guess I have is, and I also want to open this up if there's any questions from the audience. I'm sort of tracking here the questions in the chat, but IPNS integration. There's Helia IPNS, right? And it also follows this kind of similar modular and composable pattern where you instantiate Helia, and then if you want to do IPNS, like mutability essentially, to have these mutable pointers, then you pass Helia into that. So just like from a high level, what's sort of the plan with Helia IPNS, and maybe you can share a bit more like on what's sort of next for Helia, because it is actively developed.
Yeah, so the plan for Helia IPNS is very much the same as UnixFS. I can show you on the screen. Let's have a look.
All right.
So I've already conveniently imported IPNS to create the naming system Helia. And so the way IPNS works, I'm going to remove most of this. So the way IPNS works is you have a public key, and you have a key, and the easiest way to represent those in libp2p in general is peer IDs. So you can create yourself a peer ID. So I can create key info equals await Helia libp2p keychain create key my key. So what this is going to do is it's going to create a key pair. It's going to store it securely in the libp2p keychain, which encrypts it inside the data store, so it's encrypted at rest. All very secure. I'm going to unsecure it by exporting it. Chain export info.name. Okay, so now what? Well, so now I have a key and I have a CID. So what I want to do is create an IPNS record, which basically corresponds to this key and points to this CID. So what I can do is now, because I have the name system, I can name.publish the peer ID, the CID, which is the value CID, and that will publish an IPNS record for this key that points to the CID. At the moment, it's not going to publish it anywhere, so you need to pass some routers in. So one of the routers that you can pass in is the DHT router. DHT. And there's two routers that are available. There's DHT and PubSub. So I can pass in DHT and PubSub, and these will now attempt to publish this IPNS record for this key for the CID. But don't take my word for it, because it might not be true. So what I can do is I can pass in a non-progress handler, and we can see what's happening. So here's the event, and then type equals, and look at all these events. There's all this stuff that can happen. So you've got publish events, routing events. So there's a whole bunch of steps that it will go through. So it will create the record. So it will start the publishing, and then it will put the record onto your local data store, and then it will try to publish the record on any routing systems that are configured. So we've got the DHT and we've got PubSub here. So I'm just gonna log out the event evt.type. And we can see what's happening. So some things I will need to do is I will need to start the Helia node.
And one of the things you mentioned is that if you're doing this on the DHT, you probably want to have some peers already when you're doing the publish operation, right?
It's very true. So in order to actually do any operations, you need peers to send the data to, and when the node first starts up, it may not have peers. So I can actually just run it and it will fail because there won't be enough peers yet. So normally you want to wait a few seconds. Invalid key type. And I should probably specify a key then, shouldn't I?
Oh yeah, like an EC 25519 or something. I think it accepts a string, if I remember correctly. Yeah, ED. Yeah, that's the one. Okay. Routing.dht. Okay, it's having. Oh, I think that's because you actually have to pass into the libp2p instantiation the Kademlia DHT.
Ah, yes, it's missing. Good point. Okay.
But maybe we can follow up on this and share a runnable example after the live stream.
Absolutely. Let's not bog us down. I've been talking for way too long.
No, this was great. I dropped the link already in the chat, so you can check it out. It's in the IPFS examples GitHub org, and there's a whole repo there called Helia examples, and we'll be adding more. You can also open an issue there, right? If you have a specific example that you want to explore. There's already a pull request that I opened on just connecting to another peer, like I was testing connecting to a Kubo peer, and making sure, because there's a bit of not all basically transport protocols that are supported by Kubo are supported by Helia, right? I mean, you have WebSockets, Web Transport isn't supported by Node.js because it's built on top of Quick, and Quick isn't supported either, right? So it's mostly limited to TCP and WebSockets and WebRTC.
At the moment, yeah. So there's a experimental web transport listener. There's a PR open against the web transport repo for libp2p. that had support for an experimental web transport listener for Node. But
Oh,
it's coming along. It's not ready yet, but it's coming along.
and
There's
is
also
that?
a PR against there's also a PR against Node itself to add quick support,
Yeah.
which has been open for a while. They recently actually split the crypto portion of it out from the JS portion, and the crypto portion has been merged, and that was the bit that hadn't had the most reviewing. So that's good progress on that. And when that arrives, then yeah, Node will get quick support and it will get web transport support properly soon afterwards, because web transport was built on top of quick.
Great. Alex, one final question that I have before we wrap up here. So these days there's like now more and more different JavaScript runtimes. There's Bun, there's Dino. Can you use Helia in Dino? Is that possible? Or and the second question is the browser, obviously.
Yeah, the idea is it's going to be runnable everywhere. So we're trying very much not to depend on core Node APIs. We want browser first, like everywhere as much as possible. Anywhere we do use core Node APIs, the idea is you'll be able to swap out
Okay.
whatever's being used. It will be isolated and you can swap it out for another implementation that works on the platform that you have. But we very
Gotcha.
much want web crypto first, and no more like crazy enormous JavaScript implementations of things and that kind of stuff.
Cool. Anything else you want to share before we wrap up?
Just that I'd love people to get involved. So please do check out the Helia repo. I'd love help like porting some of the examples and expanding like the file system support, because you've noticed there's no UnixFS support in Helia's core. It's a module that gets added on, so you could then have other file systems. So
Like
WinFS, for
WinFS.
example. Yeah, I'm very interested in
Have you
WinFS
been
because
speaking to the Fission folks, by the way?
not for a little while,
Okay.
but I could, I track some of the repos and things. But it solves a bunch of the problems that we were trying to solve with Unix v2, but it never quite saw the light of day. So it's great that like another implementation of a file system has sprung up. And because Helia is just a block store and a data store and a libp2p, you could treat WinFS as if it was a first-class file system, the same way that JS, IPFS, and Kibo treat UnixFS as a first-class file system. So I'm very
Gotcha.
excited about it.
Thank you much for coming on and for having the courage to demo on a live stream, despite all the technical difficulties. Hope to see you here again soon when the API is a bit more mature and we have a bit more runnable examples so we can work through them.
Awesome. I look forward to it too.
Thanks, Alex.
All right. Thank you.
Okay, and with that, I'm really excited to bring our next guest for today. He probably needs no introduction, but I will give him the introduction. So David Aronchik, he's leading the Compute Over Data project, and specifically the Bacalhau project at Protocol Labs. Some of you may know him from the container orchestration space, right? David, you've been involved in this cloud space for quite a while, and you've now sort of shifted into this new area.
Yeah, exactly. Thank you so much for the opportunity to come chat. Boy, I loved that last demo. Though that said, I can't. I will never love JavaScript. I just won't. I mean, TypeScript's better, but I will just never love it. It's not in my DNA. But that
What are
said,
your
I'm
languages then?
fantastic. Well, I'm pretty boring actually. I probably do most of my stuff in Python. It's just so approachable. The project you're about to see is written in Go, and I help do a lot of that work. Go is really well designed. I like it. But like most folks, I'm just obsessed with Rust. Like I'm the guy who really really loves type safety and really loves like strongly typed languages. I just think if a compiler is gonna be smarter than me, it just is. And if I can give compilers intelligence about what my intent is, then do it for me and help me make less mistakes because I'm a disaster. And that's one of the. I mean, don't get me wrong. Like JavaScript, TypeScript it brings us very far away there. Strongly typed Python brings us there, but like Rust and memory handling and things like that, you're just like, holy crap! Why isn't everything designed this way? Even in Rust. The error handling, right? The fact that the compiler tells you exactly where things went wrong and like where you forgot your references and things like that. It's just so well designed. And yeah, that's I could rant about languages forever. And everyone's fine. It's the right language is the one you're most productive in. You and your org. But if I had my druthers, that's my preference.
Gotcha.
Anyhow,
So
I
you,
loved watching that. That's fantastic.
I appreciate that. And it's just a beginning. I sense. You've actually been involved in some really important developments in scalable compute. With your work on Kubernetes and Kubeflow, right? You were the co-founder
Yeah.
of Kubeflow, and you were the product
Yeah.
manager for Kubernetes. And Kubernetes, some people may be very familiar with it. Some people don't even realize just how broad of an adoption it's reached at this point.
Yeah, it's insane. I keynoted the first what do you call
KubeCon.
it? First KubeCon, and it was a room of I don't know. I think it was like 400 people in downtown San Francisco. Probably less than that. Probably like 200 people. One of those just standard like hotel conference rooms. The last one I keynoted, I spoke to 8,000 people. It was just kind of like insane, the journey, and that was 5 years ago, 6 years ago. So it's been progress, and so much progress since then. Yeah, for those that don't know, Kubernetes, it inherited a lot from the way that Google used containers, but it was not a Google project. It was very much done in collaboration with Red Hat and IBM and CoreOS, who ended up becoming both Red Hat and IBM, interestingly, and a lot of other things like that. But it was just the problem of how you take a binary package, in this case a container, and distribute and run it in a reliable way where you don't have to think about networking, you don't have to think about mesh, and you don't have to think about ports, and you don't have to think about like space on a machine or whatever. Just let the system solve that for you, and you can just focus on packaging your application. Was really powerful, and it was quite challenging to do. And so it just kind of like caught fire. And even if you're not using Kubernetes today, you're using Kubernetes probably because so much of the infrastructure out there under the hood is using Kubernetes. And so it just became this incredibly wide thing. It's interesting because that's kind of like I stole a bunch of the original folks who were working on that to work on what we're working on now. So the idea is Kubernetes is wonderful, and it serves such an important point in your overall infrastructure as a centralized compute orchestrator. How do you say, okay, I have this large set of machines or VMs or a compute framework. I would like to push these jobs to that. But it relies on a center point of execution in order to do that, where state is maintained by the center of the cluster, and which is great if you have permanent and reliable connectivity back and forth between that, and basically free connectivity. I want to stress that as well, meaning any node can effectively contact the API server as much as it wants to get state, to get what jobs it's supposed to run, so on and so forth. What we're doing here is flipping everything on its head. So instead of saying, well, we're going to have this central orchestrator for how to run all these things, we're going to instead have a distributed state, right? Which is what the world is moving to, distributed consensus around what's going on here. And so now if I have 10 nodes and I want node number 10 or node number 7 to pick up a job, today you might have a central orchestrator say that. In the future, you can imagine a situation where all the nodes agree and say, oh, hey, number 7, you have the space to do this. You're volunteering to take that. No one else is volunteering. Great. You take the job. We all agree that the job has been picked up and is being run to completion. If it's not, we're going to check on that and make sure that the network is reliable, and number 4 picks up the job if 7 fails. But instead of ever coming back or ever having a central state server, we're doing that distributed. So that's, I'm not smart enough to come up with new playbooks. In many ways, with Kubernetes, it was like just, state and running jobs. Kubeflow was state and running ML jobs. And now, I'm on to decentralized state and running jobs. And so I'm just kind of doing it over and over.
So how this is basically compute over data, and how does this relate to Bacalhau?
So that is Bacalhau.
Okay.
Can you see my screen here?
Let me bring it up.
Sorry.
And we should be able to see it. It's
Okay.
right now, it's just
I
black.
can't flip back. Just let me know. Oh,
Let me try again.
Oops.
Still just black.
Nothing. All right. I was just sharing it earlier. I cannot seem to unshare.
Okay, let me remove the source maybe.
Can you try and eject me? What's that?
Okay, you should try. You should be able to try it again now.
There we go.
Okay.
Can you see this?
Yeah. Okay, we've got it. So
Okay,
we
great.
see this
Okay.
architecture diagram.
So this is the essence of Bacalhau, exactly what we described. So I'm laying out an architecture here. What you'll have is generally a CLI like this. Just really, even though I say CLI here, it's actually quite general. We offer WebSocket support and other things like that. But what you'll do is you'll communicate to what we call a requester node, and a requester node is not a central function. A requester node is something that sits on every single background node. Each of these functions sit on every single node, where the requester node receives the request by the CLI. So that's, again, randomly distributed, load balanced across the entire network. It will find a node. It will communicate with that node and say, hey, I have a job. The job, or the requester node, then publishes to the entire network, okay, who's got compute available to execute it. And then, in this case, it's demonstrated with one node, but realistically, it's most likely a second node that says, hey, I have compute, I can execute this job, and off it goes. Now you may be asking, well, why am I on IPFS this month? The reason is because this all sits on top of IPFS as a data distribution network, and it makes it very, very easy to interact with IPFS in a really straightforward way, because all your job is doing is accessing, absolutely vanilla POSIX interaction. So any language, anything you have today that wants to interact with IPFS can act as though it was hosted locally. Now, again, one of the things is that I should stress, your data does need to be on IPFS and available to these particular nodes, which is not always the case. And so there is a question of how do you do that? So let me actually show you how to upload something to, this uploads to Bacalhau, it uses Bacalhau to do the upload. But at the end of the day, it's just hosted on IPFS. So we have many, many, many examples here. You can go to our website, docs.bacalhau.org, in order to look at this.
I'll drop a link to that in the chat.
Perfect. So, but in each of these, you can actually run the job right here in Colab. I won't do it. I'll do it via the command line just to show you what it looks like. But for example, let's say I wanted to upload something to IPFS, right? I would say Docker run. Docker is the engine that you use to run things here. We also support WASM, and we're looking at improving this API to just make it more generic, where it might be Docker run. But for now, we do need a signal on exactly what engine you want to use. Then you give it a URL. And so I'll do that here, give it a URL. Oops.
Oh, by the way, we can't see a terminal. We can just see your browser window.
Oh no.
I was like running this in my mental terminal in my mind.
No, I'm with you. All right, let me try, and maybe I just shared wrong. Entire screen, that's what I want. Okay, off we go.
Let me bring that up. Okay, can you zoom in a little bit?
Can you see my screen?
Yeah, we can see a screen. And one question I had before we sort of get into the details. So you mentioned, right, everything is sort of running on top of IPFS. In that sense, does that mean that any input that sort of a Docker container can take, like a volume, can actually just be a UnixFS directory that is published to IPFS and available to the Bacalhau IPFS nodes?
Absolutely. Now, there's a little bit of subtlety in what you described there, and I'll get into exactly how that works in just a second. But with just a small number of steps, yes, you could do exactly what you described.
Okay.
So just to show you, like uploading something simple here, we have lots and lots and lots of functions here. Unfortunately, almost too many at this point. But you can see here, here's input volumes, meaning like you could actually set a CID directly as an input volume. I'm going to do this as a URL because I think it's a fun little thing that we wrote. So if I do bacalhau docker run, oops, what happened there? There we are. And then I give it an input URL. And my joke is, I'm a big fan of cheese. So let's find a cheese URL. I don't know what happened to my cheeses. We'll do a live search here. We'll do images.google.com, and we will search for cheese pictures. There we are. And because we are good citizens of the world, we are going to use correct license rights, Create Commons. Please do this. So now let's say I like this right here. This is a Creative Commons picture. I copy the link address and we'll go back here. And I'll give it that URL, even though it's big and ugly, it is still the URL that we want. Go away there. Oops. And from there, we will use we built a container to make this particularly easy here, called our uploader container. I'm just going to grab that, and off you go. And so now what this is doing is it's going out to the URL, it's grabbing the content from that URL, downloading it, and then mounting it on IPFS. And so when I do this, and I describe the job, this is pretty technical stuff, but like you can see what I just wanted to show you in full detail. Here's the standout. It copied it, grabbed the URL, downloaded it, and moved it over. And then when it finished that job, it now has the images available to bacalhau itself, or available on IPFS itself. So when I go and do this, it's going to fetch the results of the job, which takes just a minute.
So that means that an executor node on the bacalhau network actually did the job of fetching that URL that you passed in.
Exactly right. I don't know what's going on here. Why are you taking so long? Maybe my network connectivity is not so good. But I ran this earlier today, just grabbing the repo. So I'll go and show you what this looks like. So we'll do that. File exists. Sorry, because I already did this earlier today. But you can see here, I downloaded the README from our bacalhau network, just an experiment. And you can see here it is. Oops. Yeah, so this is, that's the, what do you call it, README? Outputs. Oh, yes, there it is. So this is the README from our network. It got the redirect notice and things like that. It was just an example. Oh, this is the one where it actually.
Okay, yeah, I see it.
So anyhow, the point is though that again, now this is on bacalhau itself. Excuse me, not just bacalhau. This is on just generic IPFS itself. Meaning, without me having to do anything IPFS add or anything like that, I can just swap over and do that. And to your question, it doesn't just have to be a single file. Here, for example, you are downloading and extracting an entire S3 bucket onto bacalhau. Here, we have a simple command to do this. I mean, we wrote a script to do it, but it downloaded, all of these various images or things hosted in an S3 bucket to this, and it gives you a resulting data set. And those data sets can be reused in any various ways. But here you can see each one of these things, one at a time, was uploaded from that. Or you could do it all at once. Yeah, exactly. So again, the point here is that it's an incredibly flexible network. The idea is anything you want to run, in a container, or anything that you can run as a script can be run on here. And I know we're out of time. I'm more than happy to kind of talk more about it. But my recommendation for anyone listening would be just go and check out, our network. We have Stable Diffusion, we have OCR, we have Bloom for audio. These are all just examples in our network showing you how to do it. Molecular dynamics, model training, you name it.
So I'm curious, by the way, we're not rushing on time if you're okay for a couple more minutes.
No, that's great. I'd love to.
So I'm really curious to hear, so how would you compare like Bacalhau to other, say, batch processing tools, or like just these kind of like generalized compute tools? And where do you think, like, is Bacalhau a new category of tooling essentially? And what do you think are some of the great use cases for it?
Yeah, so the way to think about it is that it's certainly right now, it's a much more sophisticated and reliable batch runner. That said, it can do a lot more, but one thing that we see over and over again is that a batch today is something that is often hand-rolled and very unreliable, right? Like if you're, I don't know, have 20 nodes, you might run a single SSH command across those 20 nodes, try and figure it out. And you have all kinds of like crazy error handling, and got to make sure like what happens if you can't connect to the nodes, what happens if you can't do this, what happens if you can't do that. You can run privately your own Bacalhau network on your own machines and just watch it. And again, the state is maintained by the entire cluster. So you don't have to set up your own Hadoop or Spark or Dask or anything like that in order to do it. The network that you set up knows how to start and maintain and run those things. Now, that said, this isn't a replacement for those. It's a complement, because in a lot of ways, those centralized servers serve a very specific and important function in your network. They are high performance, they're high throughput, they're like designed for lots of people to collaborate together and things on. But they're being reused for a lot of things that are pretty straightforward and boring and not high throughput. And that means that they are very costly to maintain. They often have way too much data in them and things like that. If you could instead flip that and run the jobs on the nodes where you are actually available, and either idle compute or the data is there or the data was generated, you can see that makes those downstream clusters much more efficient, because now they're just doing the thing that they are great at rather than being reused, kind of like using the end of a screwdriver to hammer a nail in.
So would it be fair to say that like it is a common use case to deploy a private Bacalhau cluster? Like say an organization that does research and quite like compute heavy stuff.
Absolutely. We think very highly of that particular scenario. We think it is critical that people be able to use their IPFS clusters on-prem in their particular security and other domains. We know that IPFS is used extremely broadly internally for folks, through things like IPFS cluster. So for us, it's incredibly important that we support that. And again, the point is, because these nodes are already sitting there, often with idle compute, if I can run my job right next to where the data is being stored, then that is a home run. And we schedule with first-class IPFS constructs like CID. So you can say, I want to run this against that CID, and the network will figure it out for you. No translating it into, well, this CID was hosted on this node in this particular share, and so on and so forth. If it's available to a node and it's identifiable via IPFS, you can schedule a job against it.
And how does it tie in sort of with private data? Because I mean, private data on IPFS is also this whole area where it's a bit murky. There is an option to run a private cluster on IPFS, but is this intended for private data too?
Absolutely. So there are two things that you're touching on there that I want to touch on as well. First, we don't take an opinion about the nature of the data that you're running. So if the data is on public IPFS, but privately encrypted, then you would do exactly what you would do with IPFS today, meaning you would schedule your job to a node that had this data on it, and then you would figure out a way to encapsulate the decryption or whatever key into that again, according to your attack surface. And there's many things that you need to think through there. Do I trust the node that it's running on? Do I trust the network? How do I get them information there? This is nothing that you're not already facing when you think about private things on IPFS. But we basically just lever on top of those. So that's kind of category one.
Got it.
On the category two is what we see more often than not for these folks is doing privacy by simply like walling themselves off from the rest of the world, because ultimately there are so many attack surfaces when it comes to doing this in a decentralized way. They're still really being thought through, and no matter how cryptographically secure you are, for example, at the end of the day, unless you're doing it, for example, using multi-party compute, or homomorphic encryption, or in a secure enclave, you're going to have to trust some people. Even then, by the way, you still have to trust some people to do it that way. But more often than not, what you see is people saying, "Well, look, there's too much stuff there, and it's too much change for me to do it in that way. I'd rather just explicitly trust, these three providers over here." To go and achieve this, and then go do it. And so if you wanted to, set up your own Bacalhau and IPFS cluster in, for example, AWS that only you controlled, or in GCP that only you controlled, or spread across multiple clouds that only you controlled, you could do that. The execution framework, the constructs, everything like that are the same. It just so happens that only you have access to that cluster.
Got it.
So that's kind of where we are, I should say. We have the team is moving like mad. We have a lot of people out there doing experimentation, probing with the network. We're doing more than we have a public network out there right now already. You can join with your own machine to see what it's like. You can also run your own jobs. We have more than 60,000 jobs a month being executed across the network right now. And it's really exciting.
Great. So by running your own node in the network, you mean an executor node here? So you could actually join and contribute essentially compute resources to the network?
Exactly.
Righto.
And it's something that we plan over time to offer, incentives and things like that to reward you for doing so. Or if you want to contribute your content, your jobs, your compute to, for example, a charitable engine or something like that, we're happy to explore that as well. It is very early, so we don't have those things set up yet. But if you'd like to do it just for fun and see what it's like joining a global network, that'd be exciting.
Great. And I have to, since I have the opportunity to chat with you on a live stream, I'd love to pick your thoughts on a topic. So you mentioned, right, that you can run Docker containers and that you also support WASM. And, there's I know that there's quite a lot of enthusiasm about WASM. It's been, the enthusiasm, I think, has been maybe premature because I think it started already 4 years ago. And it seems like we're just sort of entering the phase now of broader adoption. So I'm very curious to hear your thoughts. Do you see WASM as sort of this natural evolution in software packaging or software isolation? That may have started maybe with virtual machines, and then you had C groups in the Linux kernel, and that sort of led to the work on containers and Docker, and now we have WASM. Is this you think a good mental model to think about it?
Yeah, it's exactly what I would say. WASM's pretty insane because, I was a pretty big skeptic. Not that it wasn't, useful, but again, my previous my previous experience with JavaScript and so on, it just made me question well, really, why do we need this? But then watching the designers go through and really take a very, very aggressive position on what was going to be backwards compatible, and how to build this thing in a truly encapsulated way. As much as I love Docker, it's and containers generally, there's still a lot of OS and other dependencies, innervated all the way through. And so when you think about it, right, the fact that you talked about all the ways of packaging and virtualization and walking all the way up, VMs, for years and years, and maybe still do, have the concept of a serial port in them. serial port in a VM. Like, it's just the dumbest thing. But it's because there were so many like backwards compatible like issues and things like that that you had to maintain in order to get that going. So that happened there. Then Docker and C groups and other things like that was built on top of that. And then you had lots of other virtualizations and isolation things along the way. Now with WASM, they've really taken a really aggressive position and say like, hey, look, you don't even get POSIX unless you actively ask for it, right? So figure it out. And I thought that was going to be the death knell, right? Because one of the things that Docker made so powerful in containers was that I really didn't have to do very much. There were some things, particularly around networking, that were kind of hinky as I tried to move over. But the containers as they stood were pretty compatible, right, with the underlying stuff. I thought that this was going to be a disaster for WASM. The fact that they had actively chosen to, I won't say break backwards compatibility, but certainly not included in the box. But because there were so many things happening that really didn't require POSIX, either in browsers or on phones or things like that, that didn't have any sense of like having an operating system or having file handles or things like that. And I keep anchoring on that, but it goes all the way up and down the stack. It forced a lot of people to rethink things, or they had already thought things. And what you see is like an insane amount of compatibility. So I take my Go, or I take my Rust, or I take my JavaScript, or I take my whatever, and I compile it to WASM, and then it runs everywhere, like just everywhere that has a browser, period, or a JavaScript engine, right? And that is, that's kind of amazing. Now, to me, it feels a lot like 2014, where you had this great packaging tool, and now it's up to the community to figure out how to run a bunch of them. How do I run them in series? How do I run them in parallel? How do I create a DAG between them? Things like that. These are things that are handled by your OS scheduler if you're just running natively, or your virtual machine scheduler, or Kubernetes and other container orchestrators. How are we going to do this with WASM? I think the community is still figuring it out, and you see a lot of really great stuff. I can't say enough about Fission and what they're doing to drive some of the specs around UCAN and other things like that. There are a lot of standards groups, standards bodies working on things around things like WASI and so on. And invocation, like how do you standardize against invocation across all these things? There's a lot of like work left to do, but everyone thinks it's going in the right direction, and I really do think things are going to come out guns blazing. Again, this is not the kind of thing where, just like with Bacalhau, it will not replace other MapReduce and distributed compute frameworks. WASM isn't, and whatever orchestrator they come up with is not going to replace Kubernetes, right? What you'll see, I think, is a collaboration between the two communities where WASM is the executor and Kubernetes inherits or supports execution of these like complex WASM constructs, tying them all together. A good friend, was quite obsessed with serverless for the longest time. And it kept bugging me because it's like, well, all right, I get it, but like really, all serverless is a billing model, right? You could have serverless as a VM, right, for example, but just bill by the microsecond. It would just be annoying to have to start the entire thing. But one thing that serverless really forced us to do was to force people to think about truly stateless things, or where state really lives. When you spin up your machine right now, there's so much complexity. You have state in disk, you have state in memory, you have state in the execution pattern of your program, so on and so forth. Serverless forces you to say like, well, now I'm really going to draw clean lines. And I think WASM is the natural extension of that into a packaging system. Not telling you not to use state, just telling you like, hey, I want you to explicitly break these things up because it'll help you be more scalable over time. But we're not going to get there until you get those orchestrators, and as well you get tooling that really like makes this much easier to run. If it takes me 17 tools in order to debug that, like, oh, I forgot to install a package over here, people are never going to use it. And so that's going to be up to us to figure out.
Well, the surprising thing is if you look at the JavaScript ecosystem, it feels like it's perpetually in that state of like you need 15 different tools just to get something. And yet it's still probably the most ubiquitous runtime. I mean, to me, it's honest, like against all logic, it somehow works.
Yeah. No, I'm with you. And I if I could wave a magic wand, I would, I don't know if eliminate JavaScript from the world would be the right answer. I don't want to like dismiss it, but it does break my heart that the amount of human being hours that have gone into re-implementing the exact same thing 3, 4, 5, 10 times over. Like the fact that we have, when you go out and look at any JavaScript framework out there, for example, front-end framework, and the fact that there are like 5 that have 30,000 plus GitHub stars a piece. Like, think of the number of humans who have all worked on that. Like, I'm not saying like we need a central authority around this stuff, but man, that feels repetitive. And then you get into exactly like you said, like, you know, the fact that I do Hello World on you know, in React or whatever, Angular, and it pulls in, you know, half of the internet as a dependency. It just feels like, man, this can't be right. But I'm not an expert in the field, and you know, I'm with you. It's funny because, like, in a lot of ways, Wasm, to come back to your question, Wasm kind of solves this for you because instead of pulling, I mean, like, yes, it pulls everything in, but it only does it once, and then it pins everything. And you know, it's that normally that would be like horrifically insecure, but like you don't even get networking by default. So it's like, well, you know, like if my job doesn't require networking, presto, it's you know, I handle that surface area. So you know, it's an interesting conversation to say the least.
Yeah, and I think to just bring it back to IPFS, this is one of the reasons I'm so excited to be working in IPFS land, because it seems to me that IPFS is this thing that is being adopted from the bottom up. No one's forcing it on anyone, and you see more and more adoption of it in very interesting and sort of general use cases that you can't sort of reduce to you know, some common denominator. And the nice thing about it really is, like, I mean, this idea of content addressing, decoupling the way that we address data from a specific server or from a specific server, it seems like that's the natural sort of evolution of the internet. In fact, it seems like that was the initial promise of interlinking the web, this whole idea of linking, decoupling that from specific servers.
Right. No, look, I'm completely with you. You know, not to get too philosophical here, but the ultimate problem is humans, of course, right? Systems know how to do this really well, but somebody came along and said, well, what we really need is a URL, because people need to know how to spell where they're going. And you're like, well, fine, but humans are messy and like irregular, and I'm going to want to type in whatever, you know, news.ycombinator.com rather than trying to figure out exactly what web page I was supposed to go to and so on. But one is deterministic. Like, I guarantee if I go to this SID, I either get nothing or I get the SID, right? I get the content that I was expecting. There's no going to news.ycombinator.com and every day it changes, like the same URL, different content, which is like a disaster from a computing perspective, right? So yeah, I mean, that's the dream, and the problem is no one's really figured out how to merge the two. And part of it is like on both sides, right? On the URL side, like how do you provide something that is human readable and approachable, but like still deterministic in some form? And on the CID side, you know, we've had multi-hashes and other things for years, but like I don't think we've had anything near as sophisticated as CIDs with broad adoption, right? And academically, of course, these things have been out forever. So I think you've hit on a really important point. You know, not to come back to Bacalhau, but that is one of the reasons why Bacalhau is so powerful as well. Instead of you saying, well, I'm going to execute this job on this share, I'm going to execute this job against this data set. You figure out where it is and go execute it. And it is really a very different way to approach it. And so, you know, again, the end of it comes all the way back to what you said at the beginning. You know, I really do think this is something super powerful. In the Kubernetes world, the reason I came to work at Protocol Labs in the first place was in the Kubernetes world. I don't know, literally the third or fourth feature I ever wanted was, hey, don't make me think about how to store my data across we have all these VMs. Why don't we allow people to think about these VMs and the storage in a unified way? And a lot of very, very smart people inside Google who I was talking to and inside the Kubernetes community would say, like, that's way, way harder than you think. And that's true. And they were absolutely right. It was way harder than you think. How do you think about, eventual consistency? How do you think about read-through caching? All these various things, right? IPF, when I first talked to Juan and Molly and all the senior people who have worked on IPFS for years, I heard their vision. And again, the IPFS community, I didn't know about the IPFS community. I was just talking to Protocol Labs people, but then I learned a lot more about the fact of how community driven this is. I was like, wow, they really have something here. Now, again, that's not to say that there's not, like, the biggest problem right now is the underlying infrastructure for IPFS is amazing, but random Python developer who need to interact with it, why is it still so weird? Like, I just want to get that file. Why do I have to go and fetch it? Or why do I have to go in this? And how do I, like, shrink that gap to as small as possible? And just like looking at Helio earlier, right? Like, interacting with that felt like, interacting a lot closer to me just on my local file system. And so that, until we get that experience, it'll be a challenge, but I'm completely with you. I think that this entire community has a chance to rewrite the rules around a lot of complex distributed things.
One thing I wanted to touch on, maybe you could just give us a high-level overview of, is how is the computation verifiable in Bacalhau? Because that's also a big part of it, right? Because if data is verifiable in IPFS, you're sort of expanding this notion of verifiability to the computation itself.
Just keep talking.
No worries.
I'm just going to stand off screen. Go ahead.
Yeah. So basically, my question was, like, how do we take this idea of verifiability in IPFS and expand it to computation? And I'm very curious to hear what David will tell us about this in the context of Bacalhau.
I can still hear you. How do you
Great.
The verification of the verification IPFS to verification of compute? Yes.
Yeah.
The fact is that we do the exact same thing. So one of the things that we really want to nail is figuring out how to balance not just dedicated input data, but also dedicated CIDs around functions and code, but also parameters, right? So each one of these things will have a unique hash or CID, associated with them, and that will enable us to ensure that something that that has been run before can be run again. Now, one thing is incredibly important here is the workload has to be deterministic, right? If I have a workload that says my input is, Hacker News or whatever, take your, of choice, URL of choice, CNN.com of choice, BBC. I go to BBC, my input is bbc.co.uk. My function is curl input. That's a function that I can run, but it's non-deterministic. It used network and things like that. So some things are going to be verifiable permanently. Like if I say, give me the Fibonacci sequence for 100, parameters 100, Fibonacci sequence is the function, that's deterministic. Curling, anything that accesses the network, anything that accesses time, time and date, anything that accesses randomness of some kind, those are non-deterministic. And so you can't get to verifiability until you are running on deterministic workloads. Now, the convenient part is, like, WASM, in all its wisdom, by shutting everything down, does give you the ability to turn off non-deterministic things.
Okay, so you can actually statically check a bit of WASM code and know whether it's a deterministic bit of code or not.
Exactly right. I don't think, to the best of my knowledge, that's possible with containers. turning it off to that degree, or even if you could turn it off to that degree, programmatically saying this is a deterministic or non-deterministic workload. You can do that with WASM. So that is something that we have already built many of the tooling to do. If you give us an input, we hash that. If you give us code, or any form of job spec, we hash that. And then at the end of it, we allow you to select your verifier of choice. And we have a deterministic verifier already built in. And what that means is that we can say, how did this run? And you tell us if this is deterministically correct. Now, there are a bunch of different ways to attack that. The deterministic verifier we run basically just does a cheap and cheerful concurrency check. You tell us, hey, I'd like to run this job across 5 nodes, and if 3 agree, then we're done. Again, that only works in deterministic situations. If there's any floating point or anything like that, no go. But in the future, we are talking to folks like Lurk, who have provide a simple way to do ZK proofs. That is a way to achieve the same thing, only running the job once, and get 1 to the I don't know, it's like 1 to the 100th power or 10 to the 100th power probability that this was the job that you ran, and that I think will be very, very powerful as well. There's a lot of work to do there, not on the coding. Actually, the Lurk is a fantastic language, and I love the direction they're going. It's more like there's so much optimization. Like we're talking about like 4, 5, 6 orders of magnitude of optimization before it's usable by humans.
And this is for generating the proofs, I presume, right? Because I mean, the whole idea with these zero knowledge proofs is that they decouple like the verification from the actual proving, and the proving is the expensive part, whereas the verification is cheap.
Yes, exactly right. The verification would always be like, if you did this properly, once the proof was created, it would be trivial to verify that it had been done.
I see. David, it's been a really fascinating conversation. Before we wrap up, just for our audience who's listening, or the people who will listen to this after on YouTube, I'm curious, what are sort of the best ways to get started? I know you have docs. I dropped the links to the GitHub repo. Besides that, what are the best ways to get involved, and what can we expect sort of in the coming, what do you have on the roadmap, basically?
Yeah, so right now we are marching towards 1.0. So we're stealing again from my previous playbook of summits at least twice a year. Our next summit will be May 9th in Boston, Massachusetts. We would love to have everyone there. You can find out more about codsummit.io, where everything is listed. And at 1.0, the thing that is most important to us is really achieving API stability. We're still very much saying like, hey, look, if you use it, expect breaking changes. But at 1.0, it's API stability and a defined deprecation path for any functions that are in there. But there are many, many other things that are in flight. We have a bunch of really cool features we just ran, and you can go check this out on our blog. Again, if you go to bacalhau.org, you'll see all of these links. That's bacalhau.org. You can go to our blog and see some really cool demos about using Bacalhau for streaming workloads, which I didn't even think was possible, but we have a demo of it. We have a brand new feature I announced a couple weeks ago called insulated jobs that's being worked on, where 2 orgs that don't necessarily trust each other can submit functions back and forth and then audit the input and the results as they come out. So that's really powerful. We're doing a bunch of things for on-premises and other detached workloads. And in the spirit of determinism and verifiability and things like that, we're also doing a bunch of work on something called Octostore. And Octostore is an idea of recording everything that goes through your on-prem Bacalhau network or the public one in a deterministic and verifiable way. So I'm really excited about that as well. And tons of other features. Our network is all out there, and you can go check it out.
Wonderful. We had one
You
final
said,
question from
yeah,
the
I see
crowd.
that one. So it is like a dynamic layer on top of IPFS. I would say it's pretty close to that. A cheap and cheerful way to talk about it would simply be like, imagine any IPFS stored data set. You would be able to schedule compute against that node. Now, IPFS nodes will have to opt into this and run our agent, but that should be incredibly trivial. If they don't run it, by the way, but your data is available on IPFS and someone else does, we'll auto fetch it for you from IPFS, and then it's still available on IPFS, but you're operating yourself.
Thank you so much, David. Anything else you want
Of
to share
course.
before you're up? We're up.
No, this is wonderful. Please jump in the Slack. Please jump in, email me or on Twitter or whatever you like. I'm here. I'd love to hear workloads and features, but it's just really exciting to be part of the IPFS community.
Wonderful. Hope to have you here again after the 1.0 release. All the best.
You got it. Talk to you later.
Okay, we're almost at a wrap here, and I've got a bunch of things that I still want to share today. So some of you may have heard of Blue Sky Social. Blue Sky Social is a social network that was started by Jack Dorsey, and the idea was to create something that would be much more of a protocol than a specific platform that is operated by a company. So the exciting thing is that they already have a beta going, and I just installed this yesterday. And the reason that I mentioned, let me bring my screen up. So that's Blue Sky Social. That's the website for Blue Sky. I'll drop a link to that. And the reason that I mentioned this is because they're actually using IPLD under the hood. And if you're new to IPLD, you can think of IPLD as the data layer of IPFS and Filecoin and many of other systems. And we just, in case you're sort of even curious about IPLD and what's its role, we also recently just published a blog post earlier this week. So let me share that too. Yeah, this is the blog post. It just went out. This was originally published by Michael Rogers, who was leading the project. Some of you may know him from the Node.js space. But I think this is a great introduction to the very nature of linked data, SIDS, and how that all relates to IPFS. So highly recommend you check out this blog post. I'll drop a link to that in the comments. And you can subscribe. You can already sign up to the Blue Sky beta. You can just drop your email there. I've already been trying it on my phone, and it's pretty cool. What else do we have? We have, this is something I found this morning. So someone has written a library. So one of the things I was discussing with David was using private data on IPFS. And you know what? Maybe I'll just share this whole tab. Yeah. So one of the things I was discussing was private data on IPFS, and we just had this blog. I just discovered this blog post that comes with a GitHub repository. So it's an NPM package that essentially does asymmetric, like AES encryption, and it essentially just gives you an API to do the encryption and to upload to Web3 storage, which is a nice way if you're working with private data on IPFS. So there's a whole guide included with that. So shout out to Vikas, who wrote this guide. Yes, this brings us to one of the final parts, which is the raffle. So for the raffle, I'm gonna come back in a moment and show you what we're actually raffling. So bear right there with me. Okay, I'm back. So these are the IPFS socks, as you can see. They're IPFS branded, and they have the nice IPFS theme and lattice on them. And in order to participate in the raffle, as I mentioned, you have to just sign up to the community calendar. You can do that by going to ipfs.fyi/calendar, and you can drop a link there. Yeah, you should be able to see the subscribe button if you go there. And I'm going to actually do the raffle right now. So I've got like this whole spreadsheet set up. Let's see. Okay, I see some people have signed up. We've got some more people. Okay, so I'm going to copy all the people who subscribe. I'm going to give you a couple more moments to do it if you haven't already. And I'm going to put this into the special spreadsheet that I've set up in order to do the raffle. And okay, we have a winner, and the winner is Electro Cloud. So someone who signed up with that name, Electro Cloud. I'll be sure to drop you an email to get your postal details and send you this. Yeah, the idea was just to do a bit of a fun thing and get more subscribers to our calendar. It's also worth pointing out that we have so many different events in the calendar. So we have the Interplanetary Office Hours. That is later tonight, and that is hosted by Discordian, my fellow IPFS developer advocate, Jenks and Dawn, although I think Jenks won't be joining because he's on the way to ETH Denver. And speaking of ETH Denver, I believe that there's a bunch of events that are happening. If you're going to ETH Denver, you will probably find some of the crew there. I will try to find some links if I can and share them in the chat. And then finally, we have IPFS Things. So if you're actively involved in the IPFS community, in building IPFS, then you may have heard about IPFS Thing. This is an event that is targeted at the implementer community. There's going to be talks, workshops, discussion circles, hacking time and whatnot. And it's a great chance to meet all of the fellow IPFS implementers. So that's the website. You can already have a look at some of the schedule. It's a great event. Highly recommended if you're involved. And with that, I'm just going to open up for questions. I know we're way over time, but this is the nice thing about these live streams. They're pretty dynamic. So let's see. Okay, 1 second. Okay, I don't see any questions in the chat. So with that, I want to thank you for joining today, and we'll see you here next month. And also thank you to our guests. We had David and Alex, and if you're watching this after the live stream, then we'll be adding the timestamp. Sorry. So with that, thank you for joining, and hope to see you here soon.